Okay, so welcome to section 11.2, which is arithmetic sequences. Arithmetic sequences. Nope, not going to autocorrect. Okay, so definition. What is an arithmetic sequence? Okay, so an arithmetic sequence that's what we're defining. So an arithmetic sequence is a sequence. It's a sequence, well, of course, that's redundant. A sequence with a fixed difference we call it the lowercase d, between subsequent terms. That is a sub n minus a sub n minus 1 is going to be d for all positive integers n. Okay, so let me write it more explicitly. A sub n can be written as a1 plus the common difference d, a1 plus twice the common difference d, a1 plus 3 times the common difference d, etc. We're just adding one more d each time. So let's note. So if a1 is a1 plus 0 times d, as it is listed above, and a2 is a1 plus 1 times d, and a3 is a1 plus 2 times d, then it should be the case that a sub n is a1 plus 1 less than n minus 1 times d. Okay, so for example, so determine the first term and common difference of the following sequence. So determine the first term and common difference for the following arithmetic sequences. Okay, so number 1, let's say we have 1, 6, 11, 16, etc. Okay, so I claim that a1 is 1, and a sub 2, oh, what the heck? What just happened? Okay, that's weird. What? Oh my goodness, what in the heck just happened? Add to favorites. Okay, what? Okay, I guess the ghosts are out. It's almost 3 a.m., so maybe that's it. Okay, so a sub 2 is equal to 6. A sub 3 is equal to... Yeah, I gotta rearrange this to try driving me crazy. A sub 3 is equal to 11. A sub 4 is equal to 16. So that's all I have. But I claim the common difference. 6 minus 1 is equal to 5. I claim the common difference. 11 minus 6 is also equal to 5. And I claim the common difference between subsequent terms is 5. So therefore, the common difference D is 5. And of course, the first term, A1, is 1. Oh, why is that dashed? Okay. So that's the first term and common difference. So let's do another one. It's fairly straightforward, as arithmetic sequences are. Let's say we have 9, 6, 3, 0, etc. Okay, so in this case we have that A sub 1 is supposed to be an A. So A sub 1 is equal to 9. We have that A sub 2 is equal to 6. We have that A sub 3 is equal to 3. We have that A sub 4 is equal to 0. So what's a common difference? If I do 6 minus 9, get negative 3. Common difference, if I do 3 minus 6, I get negative 3. Common difference, if I do 0 minus 3, get negative 3. So I claim that the common difference, D, is negative 3. Pardon me, minus 3. And that, the first term, of course, is 9. Okay, let's do a third one. So 1, 2, 3. Let's say we have 7, 16, 25, 34, etc. Okay, so we have that A sub 1 is equal to 7. We have that A sub 2 is equal to 16. We have that A sub 3 is equal to 25. We have that A sub 4 is equal to 34. Okay, so let's look at what is the common difference. 16 minus 7 I claim is 9. 25 minus 16 I claim is 9. 34 minus 25 I claim is 9. So I claim that the common difference here is 9. And that the first term is 7. Okay, so hopefully that makes sense. So let's consider the following. So consider A sub n equal to A1 plus quantity n minus 1 times d. So that's going to be A1 plus what I'm going to do, n minus 1, I'm going to add in 1 and then subtract it right back out. So I'm not changing anything. I'm technically adding 0. So this is A1 times the quantity. Now I'm going to group. Actually, I'm going to group n minus 1 and negative 1 to get n minus 2 times d, and then distribute plus 1 times d from that purple. Okay, but let's look at what now. I guess I should have left. You know what, I should have separated these by one line. It would have made it easier to see. So let me go ahead and space this out a bit. Okay, so next we have, what is A1 plus n minus 2 times d? Well, that should be this A sub n minus 1 plus d. So this would be the recursive definition. So theorem. So the recursive definition of the arithmetic sequence. So recursive form, rather, of an arithmetic sequence. Arithmetic sequence is given by a sub n is equal to a sub n minus 1 plus d. Okay, so let's use this. So for example, so express the following in recursive form. So number one, let's say we have the sequence 3, 7, 11, 15, 19, etc. So I claim that A1 is equal to 3, A sub 2 is equal to 7, A sub 3 is equal to 11, A sub 4 is equal to 15, A sub 5 is equal to 19. Okay, so what is our common difference? 7 minus 3 is 4. 11 minus 7 is also 4. 15 minus 11 is also 4. 19 minus 15 is also 4. So I claim the common difference, D, is 4. So this means that the recursive form A sub n will be A sub n minus 1 plus 4. That's the recursive definition, because all I need to do is add D to the previous term. Okay, so number 2, that's not so bad. Let's say we have 2, comma, negative 3, comma, negative 8, negative 13, etc. So we have that A sub 1 is going to be 2. We have that A sub 2 is going to be minus 3. We have that A sub 3 is going to be minus 8. We have that A sub 4 is going to be minus 13, etc. So what's the difference here? Negative 3 minus 2, I claim is negative 5. Negative 8 minus a negative 3, I claim is negative 5. Negative 13 minus a negative 8, I claim is negative 5. So I claim the common difference is negative 5, which means that A sub n is just A sub n minus 1, from which I'm subtracting 5. Okay. So let's see number 3. Let's say we have the sequence 11, 12, 13, 14. Well, should be simple enough. So A sub 1 is 11. A sub 2 is 12. A sub 3 is 13. A sub 4 is 14. Okay. So 12 minus 11 is equal to 1. 13 minus 12 is equal to 1. 14 minus 13 is equal to 1. So I claim the common difference, D, is of course 1, which means that the recursive formula is A sub n is equal to A sub n minus 1 plus 1. So let's note sub n equals to a1 plus n minus 1 times d, which we stated earlier, is termed the explicit form as opposed to implicit, so explicit form or recursive form. This is explicitly, so all I need is to plug in n and I'll have it. So, for example, so let's state the following sequences. So state the following arithmetic sequences in explicit form. So number one, let's say we have 9, 13, 17, 21, etc. So we have that a sub 1. Actually, let me do a sub 1 in blue because he's important for the explicit form. A sub 1 is 9. A sub 2 is 13. Oh, why did I change to blue? A sub 2 is 13. A sub 3 is 17. A sub 4 is 21. So what is our common difference? 13 minus 9 is equal to 4. 17 minus 13 is equal to 4. 21 minus 17 is equal to 4. So I claim that D, the common difference, is equal to 4. Okay, so this means that a sub n is going to be equal to a1, which is 9, plus n minus 1 times the common difference 4. Okay, so we can expand this. This is going to be 9 plus 4n minus 4. So 9 minus 4 is 5. So this is 5 plus 4 times n. Don't know why I kept that color, but there we are. So that is the explicit form for a sub n. Okay, let's do another one. So number 2. Let's say we have the sequence 5, 8, 11, 14, etc. So we have that a1, a sub 1 is equal to 5. We have that a sub 2 is equal to 8. We have that a sub 3 is equal to 11. Yeah, we have that a sub 4 is equal to 14. So what is the common difference? So 8 minus 5 is 3. 11 minus 8 is also 3. 14 minus 11 is also 3. So I claim the common difference is 3. So this implies that a sub n is going to be 5, the initial term, plus n minus 1 times the common difference 3. So let's distribute that 3. We get a sub n is equal to 5 plus 3n minus 3. So 5 minus 3 is 2. So we get 2 plus 3 times n for the explicit form. Okay, so number 3. Third time's a charm. We have 7, 4, 1, negative 2, negative 5. Okay, so I claim that a sub 1 is equal to 7, that a sub 2 is equal to 4, that a sub 3 is equal to 1, that a sub 4 is equal to negative 2, that a sub 5 is equal to negative 5. Okay, so what do we have? We have 4 minus 7, I claim is negative 3. 1 minus 4, I claim is negative 3. Negative 2 minus 1, I claim is negative 3. Negative 5 minus a negative 2, I claim is negative 3. So therefore, my common difference here is negative 3, which implies that my explicit definition will be a1, which is 7, plus n minus 1 times the common difference, negative 3. So distributing the negative 3, we get that a sub n will be 7 minus 3 times n plus 3, because two negatives make a positive. So wrong color. A sub n. So 7 plus 3 is 10. Minus 3 times n is the explicit form. And there we are. I will see you guys in the next section.